Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Today we are going to discuss our lecture number 4, relational database systems, and in today's lecture we are going to discuss relationship, joins, how you are going to implement your joins, how you are going to implement your connection between entities, and then we are going to study our integrities. Today we are going to discuss relationship within the database relationship, in which we are going to discuss joins, what are the roles of keys. Basically these are the primary keys, foreign keys, and some other type of keys, including unique key, composite key, super key, and many other keys as well. Then we are going to discuss integrity constraints within our database, then domain integrity, entity integrity, referential integrity, foreign key integrity as well. Okay, first of all, database relationship. Basically, the relationship is a term in database that will connect two or more entities in order to fetch or extract records when we or user needs. The main feature of relational databases is relationships, and on the basis of such relationship or these relationship, your data is going to be sort, update, delete, and extract on your screen. Different relationship types control how the data and table relate to one another. Okay, before explanation of this line, I will explain to you. If you are going to use Oracle, then there will be a different syntax and different logic of SQL that you are going to implement. If you use PHP then the logic and the syntax will be different. If you use MySQL server or SQL server, then the syntax will be different. Okay, so these three major SQL database compilers are available in industry, and you can use them for educational purposes, and all three have different syntax, but they commonly use SQL as their source code language. Okay, now coming back to the relationships. How relationship controls the data and entities means tables to relate one another. In MySQL, if you use different syntax, then and if you get familiar with one syntax, then it will be easy for you to write the exact syntax code in SQL or MySQL queries. But it is totally up to you that which term or which server that you are going to select, and it is up to your ease, or it is totally up to you on your wish which data center, or you can say which data compiler, which source code compiler that you are going to use. It's totally up to you. Establishing links between tables through relationships makes this database type unique. Why? Because other databases that we have studied in the previous lecture don't have such type of uniqueness, because they don't use relationships. And knowing how relationship works helps broaden the database modeling capabilities. So, relationship basically doing an extension in handling large sets of data. Relationship: any association between two or more tables, not only two entities, between two or more tables is called relationship. And how it will get controlled? Because of its type. Relationships are of three types. Can you please guys tell me what are the types of relationship that we have discussed? Any one of you?
So there are three types:
Okay,
one-to-one, one-to-many, or many-to-one, and many-to-many.
thank you, Abdurrahman. There are three types of relationships. The first one is many to many, which will we broke down into one-to-one relationship and one-to-many relationship. These are the three types that exist in relationship. So, on the basis of these type we are going to control the database structure and the data. In one-to-one relationship, there will be only one record in the first table that will be associated with only one record in the second table. Means one-to-one relationship says there will be only single record in a single time that we are going to deal in these databases that will be connected by us, means one-to-one relationship, and there will be only one record in one time that we can associate with us. But in the other hand, one to many relationship says there will be multiple records in one time can be associated with single tuple or single entity in one time. And many to many relationship says there will be multiple relationship or multiple records of first table can be associated with me as second table. Now, the problem here is if there is multiple records that will get associated with second tables, then there will be a problem in fetching out the results. So we will broke down that structure of many to many relationship into one to many relationship and one to one relationship. And it is totally up to the situation and designers. Entities takes part in relationship. Entities means table. It is represented by diamond shape. A relational database collects different types of data sets that uses tables, records, and columns. It is used to create a well-defined relationship between database tables so that relational databases can easily store these data. For example, relational databases such as Microsoft SQL Server, first engine, Oracle database, second engine, and MySQL, the third engine. MySQL can easily be executed on PHP compiler zone. Okay, you can turn on the Apache and MySQL server on the XAMPP server control, and then you can use over the screen of PHP There are some important parameters of relational databases. Now, the parameters of relation database start. It is based on relational model. Okay, done. Each row in table have a unique ID. Done, because unique ID act as an identifier for the record in the entire database. Each row in the table have unique ID means key. Columns of the table holds the attribute of data. Attributes of data like address, like email, these are the attributes of the data. Employee table means relation or a table name. Here is the employee table. Employee is the entity. And now columns are storing the attributes of the data employee. EMP ID, employee ID. Column stored EMP ID attribute. And it is the auto incremented column. Auto incremented means whenever there is incoming of new record, it will get auto incremented in itself. EMP name, employee name, employee age, and the country name of employee is the attributes that is holded by the columns of the relation. Types of relationships: one to one relationship, one to many or many to one relationship, and many to many relationship. One to one relationship. Here you can see the figure, customer table and the order table. One record is associated with one record in the table B. It is used to create relationship between two tables in which a single row of first table can only be related with the single row of the second table. Similarly, row of second table can also be related to any other one with the next table if we follow one-to-one relationship. Okay, and in one-to-one relationship, we are going to connect it with primary keys. Primary key of table A means customer is related to the primary key of table B, so that only one record in first table will get connected with the only single record of second table. One to many relationship. The first record of first table can be associated or related with the multiple records in the second table and vice versa. It is used to create a relationship between two tables. Okay. Any single row of any table can be related to multiple rows of another table. Okay. In database, many rows of any table means, for example, you don't know about the tables, but designer asks you need to implement one to many relationship generally. Then you will ask him, I have the idea of this means one record of any table means single record of any table in the entire database will be associated or related with the next table multiple records. So this is how one to many relationship will be implemented. Then after that, if designer don't tell you the entities, then you can ask, or suppose any two tables that can implement one to many relationship, just like customer and order, just like teacher and multiple courses, or student and multiple courses. So these are the entities that you need to observe which two tables can hold one to many relationship. Okay. Any single row of first table can be related to one or more rows of second table, but the rows of second tables can only relate with only the single row in the first table. Means if we try the vice versa of person to games, then it is not possible. It is known as many to many relationship. Okay. Now, if we want to produce many to one relationship, then we have second example, which is student and teacher. We can also place student and courses as well, because one student can hold multiple courses at one time. But here the example is multiple students are getting study by the single teacher. Just like this class, you are multiple student and you are under the observation of a single teacher. Okay. Now many to many relationship. Many to many relationship will be created in two tables. Each record of first table can be related to any record or no record in the second table. Similarly, each record of second table can also be related to more than one record in the first table at the same time. It is represented as n ratio n relationship. For example, there are multiple people works on in multiple projects in the same company. Okay, organization is same, but in that organization multiple projects are running, and in the running of such projects multiple resources or multiple employees are getting used. Here are the symbols. Okay, one to one relationship will be denoted with single line on the both end. Many to many relationship will be denoted as crowfoot symbol at the both end. And if we are going to use one to many or many to one relationship, then there will be single line on the one side and crowfoot line on the many side. For example, if we are going to use one to many relationship from first table to second table, then first table holds single line and second table holds crowfoot. and vice versa. If you see double single line, then it means there will be only one and only one. Just like self join, we are going to discuss what is self join. 0 or 1. Whenever you are going to use one to many or many to many, then there will be a condition where you will find zero record. Okay, while fetching out or searching some record in the entire DB, one or many, zero or many, you will see one or many, one and many, such type of single in the entire DB. Now coming on the other symbols, if you are going to denote entity, then you are going to use rectangle. If you are going to show weak entity or a dependent entity, then you are going to use double rectangle. If you are going to use diamond within rectangle, then it means it's an associative entity, the table that is the child table of some table. Okay, and hierarchically it consumes relationships of one to one. If you are going to use relationship, then you are going to use diamond. Identifying relationships, then you are going to choose double diamond. Mandatory relationship is now going, you are not going to use mandatory relationship. Okay, employee ID, employee name, such type of attributes will be observed in circle, or you can say oval shape. Key attribute will be in oval shape but underline. Weak key attribute. Weak key attribute means such attributes that are dependent on other attribute like address or first name, last name. These type of attributes are dependent. Just like last name is dependent, so last name will be denoted in oval shaped with dotted underline. If you are going to use multi-valued key, sorry, it will not be used in your DB. And derived attributes. Basically, derived attributes are the child attributes that will be, you can say, nothing in the data set or only single in the entire data set will, but will be stored in the database as an additional information. Okay, now we are going to use joins. Basically, joins are the relationships, how you are going to join your database. And for joining and getting results out from the database, we are going to study the exact syntax and query. Alright, now we are going to use our joins. The first one is inner joins, joins, inner joins, then outer joins, then join. Now we are going to discuss our only join. How you are going to write your join. The first thing is you need to, now here is the query that you are going to use to fetch the results. Select. Select is the keyword and will be recognized in SQL. Okay, so you need to write it in the capital. Let's say you can take orders dot id, use this one, then it will be a, if you use dot, it means it is associated, the next thing that you are going to write will be associated with this relation. So I have write order ID. It is the attribute name of order table. Customer dot customer name order dot order make d, or you can underscore do underscore order date. Now what it will select in order to join two tables, means order and customers, it will select order ID from order table, customer name from customer table, and order date from order. Okay, it will get select these attributes. Now the next thing is you need to write from, you need to write first table name from orders table. Okay, then you need to specify which join you want to use. For example, if you want to use inner join, then you will write inner join. Okay, what you will write? Inner join. Then at which table or at which attribute, by which attribute you need to join your query. You will say I need to join customer on orders dot customer id, where is a keyword, where customer dot customer id. Okay, here is the join that you need to select. It says select order dot order id, means order select order id from order table, customer name from customer table, and order date from order table. You specify we have selected orders table. Now you need to implement your inner join. The join has been done up to here, but now you need to specify which join you need to do. You say inner join customers own orders. So the first table will get customers. Own is a keyword. Okay, and whenever you use where, at some queries you need to use where. Where is a keyword. Then here you need to specify such type of condition where the records match, where the records match. Okay, so in such type of way you are going to implement your SQL queries. Now it says do an inner join with customers own order table, but how? Order dot customer id, select or customer id that is present as a foreign key of customers in the order table, where you find customer id that is equals to the customer id into orders table. So basically one to many relationship is implemented with inner join. Okay, now you need to see the customer id column in orders table. Okay, customer id column in the orders table, basically this one, that is acting a foreign key from customers table in orders table, refers to the customer id. Why? Because it is acting as a foreign key of customers table. The relationship between these two tables above that we have done is implemented with inner join. Okay, now here you can check ordered id, customer name. This the query that we have written in notepad will generate a report. This query will generate a report, and the records that will get matched according to that query will be look like this: order ID, customer name, and order date. This will be done, and you need to done it within your database whenever owners, admin want to see some record ID and customer name and at which date the customer did such orders. Here is a demo database. Basically, this database is from your Honeybee Stafford. Okay. Now you are going to check here. We have done SQL inner join, and this syntax will be available to you guys on W3 school as well. Okay. Okay. Now left join. Thing is here. You need to replace left join, and you are going to use order by, because you need to specify how the records will get sorted. Then you will use order by customers dot customers name, whatever the customer name start, like A for apple, B for ball. The A record will be displayed on first, then B, then C in alphabetically orders. If you need to specify with ID, then the most lowest numbers in the ID will be placed on the top, then the increasing one. Okay. If you want to replace right join, then it will be the same of left join order by. And if you want to use order by with order ID, employee name, or employee ID, it is totally up to you. Okay. Here the employee ID are the manager, employee ID is the staff. You can replace the employee name is like staff name, or manager name, or you can say admin name, whatever the attributes that you want to deal with. Okay. Basically, here in right join you can see the figure, table 1 and table 2. Let's take an example. Table 1 is the customers table, and table 2 is the orders table. Whenever you need to fetch the results from orders tables, means table number 2, you need to implement right join. Okay. Why? Because the foreign key of first table will be, sorry, the primary key of first table will be acting as a foreign key in the second table from table number 1. Okay. And from the reference, it is using one to many relationship, because in one to many relationship you need to refer someone as an ambassador into the next table, and that will be the your primary key. Primary key will act as a foreign key in the next table that you need to join. And if you want to view or fetch all the records that you need to match from a respective record, like you need to view the record of name Usman. Okay. Then all the records in the table number 1, means customer, that name that stores with the name Usman will be displayed on the screen if you use left join. Okay. Now we are going to view. So our joins are completed. The last two joins are outer joins, right? Basically, outer join is used to display all the matching records in the both tables. For example, if Abdullah want to see customer record that name with Ali, so what he need to write? Select, sorry, select will be in capital. Select column name, customer dot customer name. Okay. Which will be Ali. customer dot customer name, then from from table name. Now the table name will be customer. Now Abdullah will specify I need full outer join. So you can say outer join. Full outer join with table number 2, which is orders. Sorry, order is orders. You need to take care of syntax, capitalizations. So here we have used capitalizations of your characters because it is case sensitive and will produce error if you don't take care of order. Now you need to implement on which table on. Now you will say customer dot customer id where. Now the matching record will be order dot orders name, or you can say I where customer name is equals to Ali. Okay, here we have done a faulty. Now check if there is any issue or you need. Yes, we have written customers and customer name. Here you need to specify I need to see customer name from customers. Full outer join is the keyword that we have done. From is a keyword, select is a keyword, customer name here we have done. Okay, customers here we have done customers id, orders here we have orders name where customer's name is a. Okay, now the query is perfect. Now if you want to fetch all the records that is matching with Ali in all tables or in both tables that is joined with fully outer, then the result will get displayed. Okay, and now we are going to discuss self join. Self join is basically very effective join when you need or when you need to display hierarchical or when you need to check a hierarchical view of your relationships. Like at first the relationship is many to many, at the second it will get into one to many or many to one relationship, then it will again distributed into one to one relationship. So whenever you need to specify or you need to check which relationship that is implemented with this table, then you are going to write self join query, or that join will make you sure which type of relationship is being implemented with this table. Self join says select your whatever the column name that you need to use. I said customers name. Okay, the column name is customers name. I need to view customers name from customer customers id and customers customer age, where whatever the condition that will get match. Customers id 1469. Okay, for example, You need to check which type of relationship is holding this table, and this table have some hierarchical view, like this table is distributed in many other child tables. Okay, just like check this one, customer table. Now the attributes are id means customer id, c name, c address, c age, c phone, or you can say c customers code, contact, and c underscore email. We will implement c underscore id, c underscore name, c underscore address, c underscore age, c underscore code. Okay, just like in KSA, now the code is plus 966 and the contacts just you can say 4567889. So this will be the contact and plus 966 will be the code. Okay. Do you know about the concept of normalization?
So, the concept of normalization is the process where the data is reorganized in the database so it meets its requirements.
Your partial, you can say your partial concept is good, but the normalization is a term or a concept in which you will break down parent table into three or four child tables. So, and after the breakdown, you will implement one-to-one relationship with all these child tables because they will get stored all customers data into their table with one-to-one relationship, so there will be no duplication of any record occur while doing input in the entire database. And you will create a first impression, or you can say your first reference in the entire database, and that first reference will act as a lead table in the database for that table, and the rest all called alias. Now we are going to implement that alias normalization and also the concept of you can say joins. Okay, self join. Now how we are going to implement it, then now check. Here is the parent table, that is customer. Okay, now we are going to split. The first one table is, this is the customers table, parent. We are going to split it in as a result of normalization. This customer parent table will get split. Okay, c underscore id underscore name. Okay, this table will be act as data reference, lead reference of parent table. Now the face of customer table means parent table is this table, customer data. Okay, and customer data holds only two attributes, which is customer id and customer name. Okay, now the second part of the table is cid address, customer is one, and acting as a pk means primary key, cid in the last, as a ID as a PK and E age. Copy customer contact C underscore details, or you can say contact ID underscore code underscore contact C underscore. Okay, basically this is a concept of normalization where you will break down parent or large attributes or maximum attributes into small tables with holding minimum attributes, okay, that are called allies. Here we will discuss dependent attributes, okay, or you can say weak attributes, okay, that we have seen in the this key attribute, weak attribute. These are the terms that we are going to cover. Okay, here we have a customer parent table that hold customer ID, customer name, address, age, code, contact, email. So this table is going to be large. And now we are going to split it into multiple tables. The first table that we have created is customer ID and customer name. Okay, and it is the lead reference of the parent table in the database. Then the second table that we have created is customer address table. It is the alias one. Customer address ID, that is acting as the primary key for table address. Okay, and customer ID and customer address will be connected with one-to-one relationship. Now check that if any other customer do an input with the same address, this means your record will get duplicated with this attribute. So system will not allow such people that do a false or false input of information into the system. Let's say Abdullah buys a honey jar from the system, but at some other part of the KSA, some other one buys the jar and do the address details of his home or his address, then system will not allow. Okay, because it's a fake or duplicated address, and this will store address and age. Customer contact table will store the contact details, and the contact ID with connected with the customer ID with the same one-to-one relationship, so there will be no duplication of any record. And email. Okay, now these tables alias 1, alias 2, and yeah, only these two tables alias 1 and alias 2 are dependent on customer data. Why? Because until these two tables are not connected with customer ID, means lead reference table, any query that designer will run will not fetch out the records that is stored in these tables. Okay, so these two tables are dependent on customers data table, means these entities are weak entities. Okay, here you can check C code and C contact. These two attributes are dependent on one another. C code is dependent on the contact and contact is dependent on code. Until if you are specifying the system with the same country, then you will not need C code, or C contact will be independent. But what if your system after some time will need third party integration, or owner need to scale his or her business in some other parts of the world, then you will need the C underscore code. So these are weak attributes. These are dependent on one another. Okay. What if user, means your stakeholder, owner of Honeybee Stepford, wants to scale up his business or her business in some other part of the world, then you will need C underscore code with C underscore contact. But if the system will be in same specific region or same specific country, then you will not need C underscore code. If you need C underscore code, then you are implementing weak attributes in the system. Means they are dependent. Contact is dependent on C underscore code until you don't have the country code of the contact of the user of the customer, then you are not going to call him or her, right? So these type of attributes are called weak attributes that can be or cannot be present in your database or in the system. Okay, so until now we have done normalization. Normalization is splitting of table into child table to avoid data duplication or data redundancy. Then we have done dependent or weak attributes, dependent or weak entities. Okay, so and also the joins as well. Right join is done, out join is done. Okay, self join. All right, we have done the self join. It says self join is a regular join, but the table is joined with itself. But the main reason behind self join in the industry is whenever you need to know the hierarchical view of the table, or which relationship has been implemented with this table or the example table, then you are going to test it with self join. Here you can see table T1 and T2. Okay, these are the table allies for the same table, and we have done what are the table allies. Basically the same version of the same, you can say, table, same version of the same table, or you can say the child tables. The hierarchical view is the example, but you are not going to specify the condition where a dot customer id is correlated. Here is the sign is less than and greater than. It is means correlated with b dot customers id. The attribute is same, id and id, table is same, customer and customer, but the reference is different, a and b, means the duplicated version of any table. The first version will call a, the second version will be called as b. Okay, customer's name as customer name 1, customer name as customer name 2, from a and b, and the accessor is b. Here the accessor is a. And if you want to specify with some city with email, then you need to specify with order by. And is the condition where a dot customer id and a dot city is both equal with b dot customer id and b dot. When id and city from first table is get matched or correlated with the second table record, then it will be get displayed. Keys. There are the types of keys: primary key, super key, candidate key, alternate key, foreign key, composite key, and unique. These are the 7 keys. Primary key is the key that is not null and unique and used as an identifier within the table. Okay. Super key. Basically, super key is a combination of multiple attributes that hold some power in the entire entity or entire relation of the database. Whenever you are going to join and fetch results on the basis of that condition, on the basis of these attributes, basically you are using super key to fetch the results from the database out. Candidate key. Basically, in database there are multiple attributes. If there are multiple attributes that stand alone, that are independent, or that can use as an identifier for any tuple in the database in the relation, but there will be only one attribute will get selected for the identification of records, that will be the primary key, and the rest of the keys that are not selected will be considered as the candidate key. And alternate key is the same as candidate key, but the remaining all keys from the candidate keys are known as alternate key. Okay. Foreign key. Basically, foreign key is the ambassador from first table in which it is acting as a primary key. In the second table from sorry, I think I am getting confused. Basically, in table 1 and in table 2, whenever you are going to implement one to many relationship, there is you need to specify a foreign key from table 1 into table 2, and you need to connect the primary key of first table with the primary key, so sorry, the foreign key in the second table, so your table will get connected with one to many relationship. So foreign key is same as primary key but displayed in the other or in next table to connect both table with one to many relationship. Composite key. Composite key basically, as name means, it is a combination of multiple attributes to make the tuple identifiable in the entire database. Unique key. You can say unique key, uh, a key that is being used for the identification of any record but in the absence of primary key. A key in database management systems is an attribute or a set of attributes, means combination of different attributes will make a set of attributes that help to uniquely identify a tuple, means row. A tuple means a row of record in the relation where no duplication of data occur. Okay. Keys are also used to establish relationship between tables and columns of relational database. In individual key values in the key are called key values. These are like 1, 2, 3, 4, 5, 6, 7. These are the key values. Primary key. Now we are going to study primary. Primary key basically is a column of table or a set of columns that helps to identify every record in that table. There can only be one primary key in one time in one relation. Also, primary key cannot be null and cannot be have same values, because if primary key have same value, then your purpose of relational database will be n. Every value of primary key must be different from the previous one. Means it will be auto incremented. It will not decrease its value. The primary key denoted with pk constraint put on a column or a set of column will now allow any of them to have any null value or duplicate. Null value means zero. You cannot specify a zero as an identifier of any record. In one relation, there can only be one primary key. Super key. Super key basically is a combination, or you can say a set of all keys that helps any identification of any tuple or any record in the table in the DBMS. This means all the all the columns of table that is capable of identifying the records in the table uniquely can be considered as super key. Okay. Candidate key. Here you can check student ID can be act as a primary key. Student last name, student first name can be act as a primary key. But we will select only one key as a primary key, and the rest, the remaining keys will be considered as the candidate keys. Okay. Candidate keys are those attributes that uniquely identify the rows of table. The primary key of table is selected from one of the candidate key. You need to select one key as a primary key from the pool of candidate. There can be more than one candidate key in a table at one time. There can be more candidate key than just one by any table, but they can never be set as an empty or can hold any empty record. Means they are required into the system. If user do not do input of these records, then the record will not be saved. Besides these characteristics, a combination of attributes also works as a set of candidate key. Alternate key. As we have seen in the previous slide, a table can have multiple choices for a primary key. However, it can we need to select only one. So all the keys which did not become the primary key are called alternate key. Same as candidate key, but candidate key can be a combination of attributes, but alternate keys are not the combination of attributes. So this is the main difference of alternate key and candidate key. Kindly remember this difference. Foreign key. Foreign key is used to establish relationship between any tables. Any foreign key will require each value in the column or set of column to get matched with the primary key of the reference table, from where it is the ambassador of that table. Foreign key helps to maintain data and referential integrity. Foreign keys are essential for maintaining difference between entities that might link with the same information but do not share similar information. Why? Because if they share, that will consider the violation of rule, and they will not consider as the foreign key. And at the same time, if they are not getting considered as the foreign key, then they are not going to be used as the primary key for the table. In such cases, the tables are linked to maintain a connection but do not entirely work on the replacement for each other. Composite key. Composite key basically is a set of two or more independent attributes that will help to identify any tuple in the table uniquely. Means whenever you are going to search, and the search will need multiple attributes on the basis of which they will combinedly search with all the attributes. As I said, they are using it as a composite key. for searching of the data. However, when taken all together, they will ensure uniqueness, just like primary key, but not acting as a primary key. The concatenated key is another name for composite key, because in concatenation you are joining more and more attributes with one another to make a single block of key. Unique key. Unique key basically is a column or a set of columns that uniquely identify each record in the table. All but what is the difference? All the values in the unique key column will be unique and not null. Okay. A unique key differs from primary key because it can have only one null value as compared to primary key, whereas the primary key cannot have null values because it is acting as the primary key. If it stores null value, then the record will get tampered and duplicated as well. Here is the all-in-one glance scenarios that you need to see: possible candidates key, foreign key relationships, foreign key, primary key, unique key, alternate key, and here is the primary key for student table and the super key, primary key and unique key and the alternate key combinedly making a super key. Now discussing about integrity constraints. Basically, integrity constraints are such type of security layers, or you can say a protocol, that a column must need to follow in order to get authentic and pure data into the columns of database tables. These are used to restrict the types of information that is going to be input and stored into the database. This means the data in the database is accurate and reliable if the integrity constraint is implemented. And integrity constraints are of different types, like domain constraint, like entity integrity constraints, referential integrity constraints, key constraint. Entity integrity constraint will be applied on the table. Constraint will be applied on the domain on the basis of which you are getting input, like age cannot be null and will be in integer. Also, the referential integrity constraints is implies on the relationships of the table, and the key constraints are implies on the primary key or foreign key. And in the primary key, you need to see primary key cannot be null. So key constraint will check if the primary key is null, then you are not going to save that record. You may apply integrity constraints at the column or table level. If you are going to implement it at column level, then you are going to check referential integrity because it is using the attributes, and attributes is going to share relationships. The table level integrity constraints apply to the entire table, while the column level integrity constraints are applied to only single column. I mean basically on the attribute. Referential integrity constraint means on the references or relationship. Referential integrity constraints is specified between two tables where they are getting connected with foreign keys. In the referential integrity constraint, if foreign key in table 1 refers to the primary key of table 2, then every value of foreign key in table 1 or must be null or available in table 2. Basically, if it is null, then it will not act as a foreign key. So there is a condition, or be available in table 2, must be present in available 2. Whatever the value that is present in the table 1 must be correlated with the values in table 2. Domain integrity. Basically, here you can check age is allowed only in integer. So this is how you are going to implement it on the attributes level, from where it will get checked while doing input. either the record the user is doing as an input is good or not. Domain constraint can be defined as the definition of valid set of values for an attribute, like email must contain at the rate gmail.com, at the rate yahoomail.com, at the rate server.com. Okay, age cannot be input as a zero. The data type of domain includes string, character, int means integer, time, date, and currency. If you applies currency as a SARs, then your currency must be getting input in the real. The values of attributes the user do in as an input must be available in the corresponding domain. For example, price. For example, price cannot be in negative, so the corresponding domain is in positive integers. Entity integrity means table integrity. The entity integrity constant states that primary key value cannot be null. This is because if the primary key is null, then you are not going to identify the records. The primary key value is used to identify individual, means separate each rows in the relation, and if the primary key has a null, then we are not going to identify our records that is getting stored in the DB. Key integrity. Keys are the entity set that is used to identify an entity within the entity set uniquely. An entity set can have multiple keys, but out of which one key can be acting as a primary key, and the rest are candidates. And from the pool of candidate key, there can only be one primary key. Alternate keys are considered as a candidate key and can act as a primary key as well. A primary key can contain only a unique and a not null value. Unique and not null value in relational database. Alright. Thank you guys. Thank you for joining the class. Take care. Allah Hafiz. We will meet in the next class, inshallah.